So where did we stop yesterday? Motherboard component is the component we are currently treating, and we've talked about a lot of them. So we went far. So we actually stopped at MOSFET, but I want to believe presently we all understand all these components on motherboard. You can all recognize resistor, capacitor, diode, transistor, and JFET. So now the next component we are talking about is going to be integrated circuit, which is IC. So basically IC is combination of all the above components. When we're talking about capacitor, resistor, and co. So somebody is complaining about screen, so let's get that fixed first before we continue. The screen, me bye.
Three 15.6.
Modulus àbí module. Ọlọ́run ẹ̀ lè pààyàn sí yìí wá.
Ìkọlù.
So here we are still trying to fix screen and audio for everybody. I want to make sure everybody is hearing me clearly. Ó parí tó bá jẹ́ yẹn la kọ́ fẹ́ correct ni mo ṣe ń béèrè, so a lè mọ̀ bóyá ká kọ́ correct ọ̀rọ̀ gbígbọ́ ọ̀nà gbígbọ́. So now we are talking about IC, and I'm trying to explain what led to IC. Whenever we are talking about components generally, are you with me? They are actually upgrading them. So basically, whenever we are talking about IC, for instance, IC is exactly integration of other components. Actually, this is just an introduction to it. So for instance, now we are talking about diode. At least you all know diode now. If you can remember yesterday, we talked about a component that uses about 4 diodes, one particular component. Just that when it comes to IC, instead of having just single component, it's going to be different components. For instance, now this is capacitor together with this diode, and let's put another one here. Let's put resistor here. This is resistor symbol. So what led this simple combination to IC is nothing but the fact that they are being packed in a box. So now if I want to label this IC based on the pin, let's count together. So this is one pin, this is another pin, and this is another pin. I can even say this is another pin to be ground, just like this. This is ground symbol. So the ground can be this part. So whenever we are talking about the pin, we can start by labeling the pin from here. This is going to be pin 1, this is going to be pin 2, this is going to be pin 3, and this will be 4, and this will be 5. So if we have an IC and we fully understood how it should work, we can as well build the IC in a separate place and connect it on the board the way it has been installed. But basically there used to be a lot of components there that you never even think of building it. But what we are trying to explain here is why they are calling it integrated circuit. If we are talking about circuit, this is exactly a circuit. This is one diode, this is resistor, this is capacitor, this is ground. So that is basically circuit. So by the time we are packing them in a box, we are trying to say this is a IC. That is why they call it integrated, as in being integrated in a box, integrated IC. So that is the message the IC is trying to communicate, a circuit that is being packed in a box. So that is it for IC section. Let me just screenshot this and send to the group. So we should check motherboard. Before I open schematic, let's go and check those IC on motherboard. I'll open the HD image. What is the symbol for labeling IC? It is being labeled with PU or U. Let me show you here. Color red. This is U or PU. And how does an IC look like? If you should look at all these labels here, if you can see all this brown, let me do it this way. Okay, let me tag this. This is an IC. This is an IC. Look at this one, it looks like MOSFET. So I have to zoom this later, but if I should zoom it, I will scatter all my taggings. So let me just explain a bit. You look at this image, this is U14 here. But for the fact that it's being named as U, this is trying to pass a message to you that this is an IC, although it looks like MOSFET, but this is an IC. So one of those ways to recognize components is the labeling given on the motherboard. I mean the board print. The label of the board print will tell you what exactly the component is. We used to have a lot of them, so you can just check to you see the label there, U or PU. Let me show you another one. This is another IC. Even though you can name this one as IC, but this one is much more advanced than IC. But this one is super IC. We used to call it IU sometimes. It has more functionality than normal IC. I told you these components are being upgraded just from diode to JFET to from diode transistor, JFET, MOSFET, all the way down to IC to Super IU. So IU is an upgraded version of IC. So let me screenshot this. I'll show you a motherboard as well. We should look at motherboard. We have different kind of IC there. We have charging IC, we have other regulators like standby IC, 1.8 IC, RAM IC, we have VRM core IC, that is the IC generating the voltage at CPU. Let me just go straight to where we used to have a lot of IC on motherboard. So from here, like this one now, this is an IC here. What is the location of, what is the board print of this IC? And the location, this is PU3. This is, as you can see, this is standby volt IC, that is 3 volt and 5 volt IC. So this is the total pin here. The total pin you are having here is exactly what you have on your motherboard. So let me see if I have the AG image. For better understanding, let me open the schematic. I have the image so that I will be able to merge both of them. Now this is one, this is the schematic, and we actually used this one yesterday. Here, this is the charging IC here. So let me open the schematic, or let me open the board. I want to open schematic that I have the AG image as well. So mostly charging IC will be closer to the battery terminal. If you should look at this place now, I don't have any IC closer at this surface. So if I should go to the other part of the board, I will definitely find one. So let me see. Since we don't have it here, maybe we don't check this place properly. Let's check again. Here, this is it here. It is very close to the lamp port here. My mouse is malfunctioning today. This is it here. This is the IC here. This is charging IC here. What is the location here? This is PU4505. PU4505. If I should open the previous image here, sorry, the schematic, this is it here, PU4505. This is it here, PU4505. So if I'm to merge these two together, this is it here, PU4505 here, and this is PU4505 here. How many pins does it have here? If I should count 1, 2, 3, 4, 5, that is 5 times 1, 2, 3, 4, and 5. 5 times 4, that's 20 pin. If you should check here, it is going to have 20 pin. Any other additional pin, it is going to be pad. So here, this is the last pin here, 20 pin. This is the VIN pin here. But when we get there fully, we'll talk about it, like when we're talking about the charging section. So if you should look at this diagram here too, we have 20 to be the last pin here, and if this pin is more than 20 pin, it is trying to tell me that we have, and look at it here. Here, look, we have 21 here. Don't be confused. It is actually telling you that the pad pin under it is counted as 1. So the pad, if we should remove the IC, the pad under it, that is the next pin to be counted as ground. So that is it for that pin number. So don't get confused. Let me screenshot this. So as for IC, you see them in form of box. The main clue here is they are being represented with U or PU. So let's go for the next component. What is the next component? We have inductor. Inductor, another name that are being used for inductor is coil. It's either you use inductor or coil. So whenever we say what is coil value, we use that term mostly. Whenever we say what is coil value, we are actually trying to ask you what is the impedance value at the inductor. If you should notice, since we begin this tutorial, you will notice I'm actually talking about coil. Coil is actually represented with PL or L, and the P in it is trying to tell you this is power, and the L there is normal coil, which is coil, which means power coil. So P is for power and L is for coil. So this is the symbol here. Correct the symbol if I'm wrong. If you should check carefully, we used to have it. We used to have more of it on the board. And look at here. I have the color here, and it is. I identify it here with the same color as well. So we should check here. All this PWM section, they will have coil. Whenever we are talking about PWM section, we said it's going to have two MOSFETs, one IC, one capacitor. It's a must for it to have coil, and I told you guys coil is a very good testing point for coil, because if I should check coil, any value I'm getting at coil is going to tell me what is the clue, what is the condition of that board. Coil is more or less like whenever you are working on board, let me just say, whenever you are working on board, whatever the condition of that section is, you will get to determine that through the coil mostly. So now if I should receive a board, I can just test their coil around, and anyone that I notice, okay, this one is defective, so I can just place my attention there, or I'll be good to go, like, okay, all their coil impedance, all their coil value is okay, so I can just proceed straight up to the next level. So coil is a very good testing point for repair. So this is another coil here. Every PWM section are tied up with their coil. So with their coil, you'll be able to determine what is the condition of that section. So let me identify them. Oh, as you can see them here. Coil is a very good testing point. At times you have small coil as well. It doesn't necessarily mean coil will be big like this. At times you have very small ones. Some coils are small, they will look like capacitor, but their color will be different. There are some issues mostly. For instance, if you go to the LVDS section, there are some coils there. Those coil, if mostly they use those coil they use coil and fuse in place of each other in that place. So sometimes if the coil is open, you have issue whereby you have display, but you won't have your backlight. We have coil in different sections, and they are doing different job there. So coil used to cut just like fuse, like higher impedance, just like fuse when it's defective. So coil again is a good point to separate board. Just in case you are having like probably short and you want to separate the board, or you want to separate a section from board, you can use coil. Let me screenshot this and explain one or two things to you about coil. Coil is a very interesting testing point. I'm actually explaining a case study here that I fixed under 5 minutes by detecting just that one coil is defective, and like the impedance is very low. So since I can discover that okay, this part is short based on this coil, immediately they brought the light. All I did was just to inject voltage there and clear the short. I tested my board and the board was working. Actually, it was 5-volt coil that was short on that board. So the essence of coil is a very the essence of coil is just for you to know. Most those output coil is for you to detect what is the condition of that particular section. So coil conclusively is a very very good testing point for repair. So now what I wanted to explain that 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 made me bring this image out when I said you can insulate. Coil is a point where you can use to insulate some section out of the board as well. For instance, although it's not the best way, but it's part of those ways you can insulate your board. For instance, if I notice there is issue at this section after testing this coil, are you with me? Let me find a good board image. So I'll zoom it out so you guys understand it clearly. I just want to change because I've been using this one. Although they are all the same thing, but let me just, for psychological reasons, let me just change it so I'll be familiar with different board. Although they are all the same. For instance, if you should look at this place on this motherboard, this is the standby section here, and this is the standby IC at the middle. Like I've told you guys earlier on, standby, you can easily detect standby section via the IC and the positioning of the coil based on experience. If you should look at these two, they are beside each other and there is an IC in between. So if I should check the value of this coil and I find out there is problem on this coil, because this inductor has passed the idea to me that there is problem at this section, I can use this particular coil to separate the board, because basically this coil is more or less like a single part. Like when we say we have different channel, but as for this section we have only this part. So if I should open or lift or separate this part, it means it's more or less like a bridge. I've insulated the track, I've insulated the part. There is no any other alternative route. So me separating it is just like me separating the problem part from the non-problem part. So if you can lift this part up, it means you are separating this particular section from the motherboard. So if I should check this place and I get my, before I lifted it, I must have been getting issue. So after lifting this coil and testing the both parts, I will definitely detect which part is having problem, whether it is from input part or output part. So now let me use schematic to explain this better. The charging section lele, standby section lele. So this is what I'm trying to explain here. For instance, when we said coil is the only part. If you notice here, this is the only part. Anything that will make me separate this part, or I break this circuit by disconnecting this, what is the condition? It means I've separated this part. This part is alone and this part is alone. This is going to be part A and this is going to be part B that happens to be the destination. If A, that is the source, is I'm getting problem there, then I'll place my attention on side A and leave side B. And if it happens other way around, probably the part A is fine and the part B is not fine, so I'll place my attention on part B and spare my part A. For instance, if I'm getting like 0.002 after in the first place by checking when they are connected. So if I should leave this coil, any part of this section that have it, if it is part A or part B that has it, it means that part is faulty. For instance, if it is part A, if I'm getting 400 and I check here, I met 0.002, the same amount I'm getting that signify issue for me. This is only trying to tell me that my part A that is 400 is fine, but my part B that happens to be the destination is faulty. So I just have to place my attention on part B after insulation. And if it is vice versa, so I will just place my attention on part A. So conclusively, inductor is a very good testing point whenever we are working on the motherboard. In fact, I can say it is a good diagnosing board whenever we are working on motherboard. So that is it for inductor. I've told you guys the symbol. Sorry, I've showed you guys the symbol, and let me find one. This is one there. This is it. As you can see, you're going to have this chip. All these components, you can easily recognize them on the schematic by only their symbol. So this is inductor symbol. After inductor, let's go for next component. Kí àwọn ọ̀tàn máìkì ẹ̀kọ́ sọ fún ọ̀gá. Ẹ fún mi ní 30 seconds. Okay, I'm back. So what's the next component we are talking here? We're talking about fuse here. Basically, fuse, you find those small fuse on the board. We all know about fuse. Fuse is just there for protection, but how do you recognize fuse as well? Anytime you see any component being labeled as F or PF, that is nothing but fuse. Basically, it used to be in color white. When I was talking about inductor, I told you guys they use inductor and fuse vice versa. Not in all cases, but in some places they use them vice versa. So it is being represented with F or PF, although we don't used to have much of it on motherboard. Here, in some motherboard, you instead of this coil, you use fuse, and that was one of the reasons why I said they used to use them vice versa. So in some boards, you get fuse there at that PF point instead of coil. Another place we used to have it on the motherboard is at the LVDS section. It's either 19 should be coming through fuse or coil at this LVDS section. We should look at this coil here. If you check, this coil are the one transmitting 19 volts from B plus to this part. If this coil is missing, so there will be no voltage here. Let me show you on schematic. L12, right? So let's search L12, L12. Okay. Yeah, this is it here. This coil here is transferring 19 volts B plus to this section. But if you zoom out, you see it here. This is the screen connector here. So this coil is actually transmitting 19 from here. After the voltage is passing through coil, then it is converting the name to inverter power B plus. That is basically they call and that laptop panel inverter. So power for that inverter is being supplied by the B plus through this coil. This inverter, although you can jump it, but it's safe to have it like this. If you check, that voltage is being fed to pin number 1, 2, 3. So if you are to troubleshoot this board at this connector point, this LVDS connector, pin number 1, 2, 3, if you can see as I zoomed out, you can see they are together, pin 1, 2, 3. You must have 19 volt there. Without this 19 volt there, mostly these two coils can be faulty. You can jump it though, but there will be no protection at that part. So that is it for that section. So I want to try and find if I will get any board that use that can find fuse on it. Although I don't use it much on motherboard. There is another fuse that used to be on motherboard that mostly engineers used to omit, and it is very, very important because if you fail to check it, you end up disturbing what is not faulty on motherboard. So at the PWM section, that top MOSFET that used to be fitted with 19 volts, at times there used to be fuse there before that 19 volts. I mean the top MOSFET, I'm trying to find it. The top MOSFET that used to get 19 volts, there will be fuse or coil there before being fitted to the MOSFET. Let me try and find it. But that's just it. By the time we are just opening through, if I should find any diagram like that, I will show you. I'm trying to find one generally, if I can even find one. You don't need to have much of them on motherboard. Fuse basically. Anything represented with PF or F is going to be fuse. This is IC like we've discussed, and this is diode. This could be JFET, it could be transistor. So because they are using the same representation, so let me skip that fuse and let's go to the next one. Or let me show you that part I said they don't really observe. Let me show you. When we're talking about PWM section, we all know that 19 volt will be fed to the drain of top MOSFET, right? Because I said 19 volt is going to every section of the board, doesn't mean it's directly entering the IC there, but it's actually getting fed to the top MOSFET of all the PWM section. So as you can see, this is it here. This is it here. At times, before the 19 volt is fed to the top MOSFET drain, sometimes they will have to put in fuse or coil. Look at this B plus here. This is the CLR voltage. Let me show you. This is it here. As you can see, after 19 volt has been generated at the CLR, the name is B plus, right? As you can see, like I've told you guys, it is called B plus sometimes too. So if you should check here, by the time it begins to enter all these top MOSFETs, let me find the PWM. Look at this place. After passing through a coil, the name has changed to B plus plus. As in, the name has changed from B plus to B plus plus. So most of the time, this fuse so everybody will have to log in, and I'll wait for a few minutes for everybody to re-log in, or those that are still available to re-log in. Cousin. So we continue after 3 minutes. I guess some people can't connect and they're trying to reach me. So let's just wait a few minutes. The call is actually affecting my network.
Ben, sir, I understand, sir.
Okay, everything that So as I was explaining before, let me share my screen. Sorry. Okay. So like I was saying, mostly what engineers used to miss to check. In fact, professionals, they will confirm every necessary requirement and they will begin to wonder why don't we have this voltage. They will forget to confirm whether 19 is even getting fed here. Truly, whenever you have 19 volt on your CLR, it means it has been fed to every part of the board. But some boards that use fuse before getting the voltage to the top MOSFET, automatically you have to confirm if 19 volt is actually getting to the top MOSFET. So conclusively, coil and fuse are used in place of each other sometimes on motherboard, but it's not all section. For instance, now like PWM section, the output coil there, you can't use fuse to replace it. So that is it for that section. So what do we just finish now? I think fuse, yeah. So let's go for the next one. So, and what is the next component we have here? So the next thing we have here now is connector. Whenever we are talking about connector, it is actually being denoted on motherboard as in the symbol is always tagged with CN. Basically, connector is just to connect two different parts together. Just the basic word connector, just to connect two parts. The representation for connector is CN or CN, or they can use any name, but you can see JP blah blah blah. But the basic thing is for you to understand it when you see it. So let me open boards and let's see the names being given to the connector in different board. The basic concept is to understand how connector work. It's just to connect two parts together. Look at this place. This is a connector. That is why they call it keyboard connector. This is another connector here, my connector. At times you only have the pad there. This is another connector. This is another connector. This is another connector. Share that one again. This is another one here. So as for connector, that is connector. Let me tag this. Like I've said, it is used to attach two different sections, or let me say it is used to divide different sections. So without explaining, you guys all understand that part. I just need to touch it a bit. This is the symbol CN and CON. Let me screenshot this and send to the group. Okay, I want to drop something here, but I think, okay, look at this place here. This is JKB1. That is the name used to represent this part. This KB actually mean keyboard, and they use J but I told you guys you can use different different connection, but basically the concept is CN, but you can use anything. You can see this one, this is J LED, that is, this is connector that is used to transmit the LED signs. This is another one here, mic, JPD1. This is JLED2. That is the second connector for LED. Because they've used this one, they don't even bother to use they don't bother to use the first one. This one can be used on another board and as another version of the board. But the concept, if something critical happened here, you can bypass that one to the JLED1 to JLED2. I'll leave that one for now. So this is another connector here, JTP1, that is for keyboard. And this is another one here, JUSB. This one is JCR1. CR, I have no idea. But if you see whatever they are connecting on that part, you will be able to interpret. So let's quickly check another board. Let's see the name used there. As in the connector. Let's see the name used there. This place, they actually use KB1. Which other one? Here we have USB 1. They don't even bother to tag connector here. They just write the function of the connector. This one speaker 1, this one power 1. That this power flex will be connected here. If I want to trigger this board, I know, okay, this is where I will trace my power pin. So I will explain little secrets for you guys about power section. So you can just go and try it when you get to office. This is another one here, touchpad. Let me check another one again. I want to try and see if I can get any board that they use C to tag the connector. Okay, let's open this as well. This one, nothing is written here. This is KBL, keyboard light 1. As you can see, this is the power for the keyboard light here. This one they use TP touchpad. It is not being used as here. The main concept is to understand all this term, because mostly at times you just find them changing the name, changing whatever, twist it. If you can understand the concept, whatever they are using, you care less about it. Your own is to understand the basic concept of it. So I don't even observe that most of these boards we are using as case study here are really strong. So first, let me tell you guys, all those companies, HP, Dell, Lenovo, they don't do their board on their own. So they have companies that are making this board for them. They call them ODM. So these are those people that will design the motherboard, then they will go ahead and make provisions for the accessories and packaging and co, blah blah blah. So here too, they don't use it, as you can see, power button 1. But those that are actually designing the board are not the brand owners. So that is why whenever you are handling board, whenever I'm handling motherboard, I don't really care mostly about whether it is Toshiba, ISA or Dell. So far I know that if this company is producing their board, this is the way they used to design their circuit. So that is it for that section. The next one we are going for now is pad. Whenever you are talking about pad, you used to call it jumper pad as well. Pad 2 is very, very important on motherboard, basically because it is used as a testing point and it is used to separate the board, as in to separate many section. So basically pad is more or less like, whenever I'm working on schematic, I'll show you guys. Okay, this is not pad. I'll show you one. Some pads we have solder, some won't, depending on the manufacturer. Look at this place now. Look at this JP2 pad. This is trying to tell me this is pad. If you should look at these two ions, they are not touching each other. This is insulated. That is, this part is separated. This is obvious. This is directly from company. So pads are attached, some are detached based on the version of the board. This is PJP 501. This particular board here, if I want to separate this board, as in if there is problem like I was explaining in the coil section, if I want to know which part is responsible for my issue, as in if there is problem at this section, the problem can be at the front and it can be at the back. So it can be from this line or this line. But if I want to separate this board, just like I've explained at the coil class, so if I want to know that, I'll have to separate this part. If I'm able to separate this part, as if I'm able to clear this pad with soda wax, if I'm able to clear this pad here, I'll be able to dictate which part is responsible for the issue. Look at this place now. After clearing, this is how it will look like. If I can separate this part, I will definitely discover where the problem is. Maybe it is from the front part or it is from the back part. So that is it for that section. Now let's check. Let me clear this, or let me screenshot first. Look at these two sections that I'm using here as an example. See, if I'm separating this part, let's go and check schematic and let's see what we are separating. Let's see what can be what can be faulty that will make us separate this part. So let's check it in the schematic. This is PJP 501. So here, let me reopen again. JP 501. So this is it, PJP 501. If I'm to separate this pad, where am I separating? So this is a very, very useful pad here. This is 1.05 voltage. You know, I said this previously. I said 1.05 is generated to get to power PCH. Now the essence of this pad now here is if there is problem at this section here. Let's assume this is the part where the voltage is coming to this PCH, and now I'm not detecting problem at this section based on this coil. So let me tag this. If there is problem at this section, let's assume this is the coil here, 1.05 coil. If there is problem within this section here, if there is any problem here, let me see, in between this PCH and its supply, its pad PWM section. So the pad here, if I can separate this pad here by getting the lead out and separating the two parts, so I'll be able to detect if the problem is coming from the PWM section or from the PCH section. Let me identify it here for you. So if I can divide it, it's more or less like me dividing the power source and the destination. So if this part A is my faulty section, I'll base my attention on part A, and if part B is my faulty section, I'll place my attention on part B. So if the problem is at part A, it will definitely remain on either one of these components, and if it is at this section of the board too, it means this PCH is gone. So I'll have to change the PCH. So that is one of the basic importance of pad. Pad can be anywhere on the motherboard. Basically, the essence of having pad on motherboard is to if for instance voltage is going to many places on the motherboard, so at times for you to know that for this section you want to separate it, so if you can get a pad at this section, it means this is the main power source for this section. So if you can insulate this section from this power that is going to everywhere, it means if you are detecting your problem from this section automatically. If the problem is clear from this section, then you can further your problem finding on every other part aside from that particular section. And if it is that section, you can stick to that section, and it will you will be good to go at every part of the motherboard. So yeah, that is the essence in a nutshell. A job was brought into my office today, and where we were supposed to get 3.3 votes, we checked and we got only 1.9 votes, and I discovered there is a pad there. So after I desolder a pad there, because there is a pad in between, so now I check again. I check at the voltage source where I was expecting 3 votes, I got 3 votes, and the other part automatically it will be 0. So far that I'm getting the 3 vote at the source after separating it, then automatically what do I have to do? I injected the I injected the voltage at the part that is on the other part of the board, and easily I could discover the component that was faulty. Although I made video on that section, it's an HP folio board, so it is among those one of my practical videos. So I will upload it, so you can easily relate the two together. What I'm trying to explain here. So I believe we are all clear with that section.
I'm fucking violent, sir.
Okay. So what is the next component we have to explain from here? Let's talk about switch. Actually, switch is not that much on motherboard. Even if there is switch, it is going to be in between connector, but basically this is switch symbol. The secret of switch is nothing but let me make this, I want to make this clearer. Let me see. Let me show you how switch work. If I have straight line, for instance, let me use my pen. If I have straight line just like this, or let me use red to symbolize positive. If I have straight voltage like this, or straight line, if I have straight line like this, this is my voltage. Or let me do it like this. I want to explain how switch work. If I have straight line like this, that happens to be voltage. Let me symbolize this with red, and it can even be ground. Switch is switch. So me having this straight line, if I have another one like this, okay, wait. Let's assume I have 5 volts on this line. If nothing is interfering in between this line, I will have a Z voltage. If nothing is okay, I will have a Z voltage at the other end. But in a case whereby the same thing, sorry, I have the same straight line, but this time around, let me do it this way. I'm trying to sketch the same straight line but with little interference. Let me do it like this. This should find, I will try and draw 2. Okay, better. So this is another line here. So let me make it straight. Okay. So if I have, look at this second line here, if I have straight line like this, and at this part automatically I will have 0. Why? This is because there is a break in transmission here. So I'm trying to draw the switch here, and look at this line here. Automatically I will not have any voltage at this part here. So by the time this switch is open at the second line, automatically I've turned it off, and on the third line, you can see by the time the switch is coming down, automatically I'll have my 5 volts. So basically that is how a switch works. If you notice your switch in the house, by the time you press it down, you have lights and at the normal bulb, but if you press it up, then the light goes off. What is actually happening there is that by the time you are pressing the switch down, it is actually connecting the 2 terminals, and by the time you are pressing it up, it is actually breaking the circuit. So that is exactly what is happening there. So on motherboard they don't really use it like that, but there is one section we use. Let me sketch this first. For motherboard, the power switch of motherboard, the concept of motherboard switch, before pressing the power, first you have 3 volts present there. The basic concept if laptop is to turn on is 303 first, that is 303 logic. So let me write laptop so you understand. For laptop, we have something we call 303 logic. Before power button, the voltage will be at 3, but any voltage that goes to ground, for instance, let's assume, let me sketch, how do I explain this better, or let me continue like this. Before pressing power button, there will be 3 volts at the switch, as in the pin for the switch. I'll have 3 volts there. If I should press power button on motherboard, I'm doing nothing but connecting the 3 volts to ground. So anything ground is 0. So if I should connect any supply to 0, any supply I should connect it to 0, it will draw it down to 0. So me pressing the power switch, what's going to happen? The 3 volts that was high before will go down to 3 volts, and by the time I release it, it will go back to 3 volts. It happens fast because you press and leave. That is the process. So that is why we call it 303 logic. So it has a component, motherboard has a component that will interpret that message, that 0 message. Immediately it hits 0. Please give me a minute here. I'm working in class. I'll call you back here. Thank you. So the IO will interpret it as that voltage going to ground means I should trigger as I launch my power processing. So if you keep pressing the power button for probably like 4-5 seconds, it will interpret the same message again as first shutdown. It has all this program in the IO. It has all this pre-programmed message in the IO. So its own is just to activate whatever you are pressing. If you are pressing for 5 seconds, if you are pressing for just 1 second, it has interpretation. It's more or less like what my boss told me is that if this voltage goes to 0 for 1 second, so I should do this. If it goes down to 0 for 5 seconds, so I should do this. That's just the concept. For instance, if there is problem on motherboard, it is possible, like power issue for instance on this section, it is possible that you are pressing the power button but the message is not actually getting to the IO. It is possible that the power switch itself the zero, the voltage is not hitting ground, that is not going to zero, and it's possible it's going to zero but without getting to the IO. So you can see fault can come from different angle of the motherboard. Are you guys understanding? ṣé àárín yẹn yé yín?
Ó kù díẹ̀ sá, ó kù díẹ̀, ó kù.
Okay, let me rephrase this. Ṣé everybody ní àbí èèyàn kan ni ó kù díẹ̀, àbí everybody ló kù díẹ̀?
Explanation.
So let me just re-explain this. I want us to have enough time for question and answer. So let me screenshot this and send.
Laptop yẹn ló fẹ́ complex jẹ for normal switch yẹn ṣe ń ṣe yé dáadáa.
Normal switch nìyẹn bọ̀ ọtí yẹ kí n wá sórí normal switch nìyẹn lóòótọ́. Ọ̀pọ̀ tí yẹ kí n wá sórí motherboard ni pé motherboard la fẹ́ treat, but kéèyàn tó lè understand anything ilé ayé ẹ máa bẹ̀rẹ̀ from imbo ni origin ẹ̀ tí ó bá gbé new manager wa. Why I have to do this is this person saying the normal switch is simple but the motherboard one looks complex. Actually, one have to understand from basic. You get, so like if you have new manager, the manager has to go through the old file so that you understand how things are being run. So all let me do like this. Let's go and open motherboard and let's talk about it there. Although this is simple, but I'm just surprised you are not really getting it. So there is, I can power motherboard in different process. I can power it directly from the IO. I can work another power for it anyhow. So even Apple, they are working with the same logic. I charge a work for like 35,000. The only problem was switch and the power button is on the keyboard, so the board was not turning on. So I worked the switch directly from the pin. So instead of me going for the keyboard or blah, blah. So you can just manipulate anything only if you should understand it. If you have any case of power issue, firstly, you don't power with the power switch to be sure that you are actually doing the right thing. You can power. You have limited time left. So let me use here. All this voltage, they are just command and message. Now here, this is the power section of this board as in power connector. Let me check the schematic and show you too. This is JLED2. So yeah, this is it here. I said I'm happy at least you guys did not understand something I've explained for the first time. So let me re-explain this. I'm actually trying to zoom bigger because of those people that are using phone. So we should look at this pin here, pin number 9. Pin number 9 here. It is being tagged as, I don't want to use pin because I will have to move this around. Pin number 9 here is being tagged as on and off. That is, pin number 9 here is going to be, let me count. This is 1, 2, 3, 4, 5, 6, and this is going to be 9. So this particular pin is the main pin that this board is using to power. So some engineers, they are fond of one bad habit. They will use picker randomly on all of these pins. It is very, very dangerous. It is safe to use meter, but if you are going to use picker, you have to be sure of the pin. Like if I'm to use picker now, I have to use, if I use picker on pin number 9, 100% my board will power. Because now based on the switch 100%, I will have 3 volts, around 3 volts there. So by the time I'm pressing that power button, it means I've connected 3 volts to the ground, and anything ground is always low. So anything going to ground will be dropped down to 0. So it is a negative power that has power that is more influential than positive power. So within that seconds I'm pressing my power button, it means I've dropped this voltage to 0, and by the time I'm releasing it, the voltage will go back to its initial state because I've disconnected it from the ground. Are you all getting it here? So that is it. What I'm not trying to emphasize here is there is a component there that will interpret the message, although we are still going to talk about that at length. So the component that will interpret the message, what I'm trying to explain, do you all understand? Do you all understand? Any?
mo ní ṣé gbogbo àyè tá a bá ti lé 3 volts our brain dẹ̀ wá sí 0 pẹ̀lú pa connect ẹ̀ máa ground táwa dá padà ṣé gbogbo ẹ̀ nǹkan báyìí ni component ẹ̀ lè interpret sí.
No, not all pin. Look at all these pin here, they have their own function. So even this one is switch, this pin number 2, but they have different function. So the one that is working for on and off, this is it here. If you look at this lead here, this lead switch here, have you ever wondered that if you should close your laptop, how does your laptop get to know that you've closed your laptop and the display will goes off? Have you ever wondered? If you should, let me explain. If you should open your screen, you will notice that there are some magnets at the tip of the screen. Yes or no?
Exactly.
Check. So look at those magnets. There are some components on motherboard. Mostly you find them at the panel. Those components, they are working with magnetic, those transistors, they're actually working with magnetic force. Whenever the magnet come closer to those components, it will trigger those components. That is why we call those that's why we call it lead switch, because immediately that magnetic force comes closer to the component, it will trip it on. Immediately you just bring the magnet closer to the component, automatically the screen will just go to sleep. If you want to practicalize this, just try to move your magnet closer, move a normal magnet closer to the part, that area where you have your switch, or that area where you have your magnet on the screen. You will notice that the screen will go off immediately. So that is it for lead switch. You can just do the practical if you want to practicalize it. So if you are checking board, if this signal is at 0%, 100% the board will not turn on. Or let me say 90% the board will not turn on because of some cases, but you won't have display. So they are actually communicating on voltage level. Whenever they get any voltage that they program them, okay, if you have this voltage, this is what it means. They will just launch the program without caring whether it is proper or it is not proper. They are actually communicating with voltage. Look at this lead switch. Whenever you have 0 volt or short circuit and let this place to 0, so no matter what you do, it will be sensing the laptop like you are trying to turn it to sleep mode, so without reversing itself. Do you all understand? So this power button, let's check where this signal is going. I've copied it here. This is it here. On and off. Okay. I want to show you the final definition. This is actually going to IU, but I'm just trying to like show you guys so that you will confirm. This is exactly how they follow signals, you can see. Look at this place. This is it here. It is actually coming to this particular component. It is going to come through a pin and goes out through another pin. That pin that is using as output is the pin that is using to transmit the message. We actually call it power button in, the one coming from switch, and power button out, the one going out of the switch. They can call it MBS on, the MBS out. So immediately this component receives, it gives out. But don't worry, when we get here, we'll get to talk about them in details and you guys will understand it clearly. So as for switch, that is it for switch. Let's go for the next component. Do you all understand? So look at this crystal here. It is actually used for chipset or those components that has more work. It's more or less like a timer. So when we are talking about IC, at those stage we are talking about time on solent. But whenever we are talking about IU, chipset, processor, all those carcos, all this one they are using crystal. It's more or less like a timely. This example is not a friendly one, so let me just leave it. Seatbelt.